Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video in which we will look at partial fractions. So they're used to perform tough integrals like this one here. So I can factorize the bottom of this fraction. It's just x plus 2, x plus 4. But this is still not an easy integration to perform. In fact, it turns out that integrating sums and differences is much easier than integrating products and quotients. So, is there a way that I can turn this into a sum? It turns out there is, using partial fractions. See, what I'm going to do is I'm going to rewrite this integral as something over x plus 2 plus something over x plus 4, because that is much easier to integrate. So now it just becomes a case where I have to find what a and b are. So if I were to add these two together, the denominator would be x plus 2 over x plus 4. The numerator would be a, lots of x plus 4, plus b, units of x plus 2. Now that somehow needs to equal 1. So let's expand. We get ax plus 4a plus bx plus 2b is equal to 1. So how do we solve for a and b? Well, notice that this is the same as 1 plus 0x. So the coefficients of x need to add to 0. So we have a plus b equals 0. And we also have 4a plus 2b is equal to 1. So solving these simultaneously, we end up getting a is equal to a half and b is equal to minus a half. And you can easily check that's the solution in these two equations. So our integral therefore becomes a half over x plus 2. And we can replace b with negative a half. So this is now really easy to integrate. Integral of a half over x plus 2 is just a half natural log of absolute value of x plus 2. The integral of this is just negative a half, and it'll be natural log of x plus 4. And of course, because it was an indefinite integral, we need to write a c. All right, let's look at another example of this. So here we have a function that is not at all easy to integrate. Our first step is going to be to factorize the bottom. So what we can do is factorize the first two terms that have a common factor of x squared. Then we can factorize the last two terms. So that just becomes x squared plus 1, x plus 1. So that's the new denominator. And we're going to keep the numerator the same for now, and we're going to use partial fractions. So this is what it's become. So to use partial fractions here, I want to be able to write this here as something over x plus 1 plus something over x squared plus 1. But when you have an irreducible quadratic, so a quadratic that can't be factorized on the bottom, you need to write a linear term on the top. We actually need it to be bx plus c. So we're going to find the values of a, b, and c so that this is equal to that. So were I to combine these into one fraction, I would end up having a lots of x squared plus 1 plus bx plus c, lots of x plus 1. So that needs to equal the numerator of the original function. Okay, so let's go ahead and expand this. So here's what I get if I expand the brackets. So what we do is just look for the different powers of x. So what I mean by that, so we have two x squared terms here with coefficients a and b. So a plus b needs to equal the coefficient here. We have a plus b is equal to negative 1. Similarly, we're going to do that for the terms with just an x. So we have b plus c is negative 2. And finally, looking at the constant terms, we have a plus c is equal to 1. So let's use these last two equations here and here to eliminate c, which we can do by subtracting. That gives us b minus a equals negative 2 minus 1, which is negative 3. Now I can use these two equations here to solve for a and b. So if I add together these two equations, I get 2b is equal to -4, which of course means b equals -2. Now if b equals -2, that means a is going to be 1 and c is going to be, so I have -2 plus c is -2, which means c is 0. So what I've done is I've found that I can rewrite this integral here as the integral of a over x plus 1 plus bx plus c. So b is -2, c is 0 over x squared plus 1. So I've reduced this here to the sum of two functions that can be easily integrated. So the integral of 1 over x plus 1 is just natural log of x plus 1. Now, when I want to integrate this here, note the derivative of the bottom is 2x. So this is just going to be negative log of x squared plus 1, and because it's an indefinite integral, I need to add the constant. And then we're done. All right, thank you so much for tuning into this video. This has been the luckiest maths teacher in the world. Have a great day.